Morning, everybody.
Good morning.
Yeah.
It is morning.
This is probably the biggest group I've had to speak to yet, so I mean, that's good that folks who want to hear a little bit about water quality and issues with maple. My name is Jason Bradley. I work for the Vermont Agency of Agriculture. I'm an environmental engineer. Most of my work is with water quality infrastructure improvements on dairy farms. But I have a background in environmental chemistry, so they kind of tapped me to work with the, yeah, very good. That's your one bad dad joke for the morning. Tapped me to work on some maple water quality stuff. Had another guy that was with the agency prior, Pat Fry. A few of you may have worked with him. Had started, doing some of this work. So, kind of what I want to do is try to give just a brief overview of sort of the regulatory framework and players involved with, regulating maple and water quality. And I just want to go over some of the water quality, parameters that we look at from state level when we think about regulating, pollutants and discharges that get into rivers and streams. And tell you a little bit about some of the research we've been doing to try to get a better understanding of what are the different waste streams coming out of sugar houses, which ones are of concern, and what are some very simple things that you can do to alleviate the most pressing concerns coming out of the sugar houses. So historically, maple's not really been, on the radar as far as water quality concerns. Traditionally, there was no, water discharge or liquid discharge coming out of the sugar house because it was all, steam fired. But with the advent of reverse osmosis, it's kind of changed the entire industry in the last 20, 30 years. And so now there are some things coming out of the sugar house that potentially are of concern. Kind of how the agency bag kind of got involved with maple on a water quality level. A while back there was a well that had gotten contaminated with some nitrates or something. I don't know all the details on that. And they were trying to investigate, where it was coming from. They realized there was a big sugar operation, one of the larger ones nearby. And so, on the regulatory level, folks just kind of realized that, nobody really had an idea of what was coming out of the sugar houses. So kind of started to take a look at that. There was also some confusion as to, who has responsibility to regulate maple as far as water quality goes. In Vermont, there's sort of a separation there where the Agency of Agriculture is responsible for regulating agricultural activities and water quality. Whereas in most states, it's all kind of put into, one place, the Department of Environmental Conservation. And they're usually involved when you have something like a point source or a pipe that you can, point to, such as a municipal wastewater plant. Maple is kind of in that gray area because, you've got a pipe coming out of the sugar house, but it's a, definitely an agricultural operation. So primarily, regulation falls to the Agency of Agriculture. I always try to give the caveat that I'm an engineer. I work with farmers to try to solve problems. I'm not an inspector or a legislator or a regulator, so just bear that in mind. So we don't have rules specific to maple right now, but maple operations do have to follow the required agricultural practices, which I have a copy of if anybody wants to look at them. Anybody that's familiar with dairy operations is probably taking a look at that. A lot of that is geared towards that. So there's nothing written in there specifically directed towards maple, but still you can't just put whatever you want into the waterways. In Vermont, for Lake Champlain, we have the TMDL, the total maximum daily load, and that's primarily regarding phosphorus, which you've probably seen in the news. We got the algae blooms. that are caused in big part by excess phosphorus pollution. So that's kind of one of the things that we want to look at in regards to maple is, what's the phosphorus loading coming out of maple sugar house. So about the sort of the regulatory framework, maple in a sense is kind of like a point source because you have the sugar house and a pipe coming out. But the sort of regulatory tool that we have available is the NPDES permit, which is what all municipal wastewater plants have to get. And you look at that, and you have you have to look at all of the water quality parameters coming out of the wastewater plant and determine how much of each pollutant can be safely discharged before it has a negative effect on the receiving water. So we have these water quality standards for a variety of things, BOD, phosphorus, nitrogen, a few other things that we'll look at in a minute. But this framework doesn't really work well for maple. It's just a little too in-depth. So I want to just jump into what are the water quality things that we're concerned about. So if you haven't heard of these, pH, that's the measure of the acidity of the solution. You got your RO wash water, that's a high basic solution, and you've got your evaporator pan acid, that's a low acidic solution. To discharge, you're supposed to discharge a liquid, it's supposed to be between 6.5 and 8.5 if it's going to reach a stream for pH. Temperature could potentially be a concern. Ideally you're not supposed to change the temperature of receiving water by a certain amount. Given that, it's usually pretty cold during maple sugaring season, that's usually not too much of an issue regarding temperature. Dissolved oxygen and BOD are two things that kind of go hand in hand. Dissolved oxygen is just how much oxygen is in the water. Fish need oxygen to breathe. And then there's biochemical oxygen demand, which is just a measure, for your purposes, it's usually just a measure of sugar. So bacteria in the water can eat sugar, and in that process of metabolism, they breathe oxygen just like we do. So if there's an excess of sugar, then they'll start eating all of it, and they'll use up all of the oxygen, and that can cause oxygen depletion and fish kills, die-offs, that sort of thing. So that's why we care about BOD, which is essentially just a proxy way to measure the amount of sugar and waste that's in a discharge. And then there's our nutrients, phosphorus and nitrogen. Phosphorus is the main thing of concern for anybody that's in the Lake Champlain drainage basin. I mentioned the TMDL that is mandated. Vermont has to try to get the phosphorus levels in Lake Champlain down to a certain level. That's required by federal law. So, we're trying to aim for an in-lake concentration in the 10 to 20 microgram range.
When you say temperature, you're talking about the water. So if we're pushing out rinse water or wash water, 5 degrees different than ambient temperature of the air or of the water?
Of the receiving water. So you don't want to change the temperature of the receiving water. And typically if you're discharging onto frozen ground and it's going over snow, then that's going to, when it reaches the stream, it's going to be the same as the receiving water. In some limited instances, if you have a very large producer and a very small stream, that could potentially be an issue. One of the things I'll talk about is sort of the variation in scale that we now have in the industry. We have, from very small producers up to very large producers. And when you're looking at the large side of the spectrum, the volumes can get really high. So a little bit more just to kind of put BOD in perspective. On a theoretical basis, I try to use this to give you a kind of a sense of scale. So syrup, finished syrup, is really just, it's a lot of sugar, and bacteria can eat that. So 2 tablespoons of syrup have enough food for bacteria to eat, and in the process of eating that sugar, they will use up all of the oxygen in 1,000 gallons of water. So it doesn't take much to really have an effect, especially when you get the concentrated sap. So
And it's not just the fish either, it's not, right, anything that's in that stream.
yeah, anything that requires oxygen.
Yeah.
I mean, mainly fish, but
Right, but
yeah.
the lizards and everything else.
So, I mean, there's a lot of site-specific things on, like, how much, that's the finished syrup.
Yeah.
There's, a lot less in raw sap, but,
Correct.
there's a lot of sugar still in the raw sap. And it kind of depends on the receiving stream. If it's a very small stream, it could have a bigger effect, but that's why we kind of care about that. The nitrogen and phosphorus, again, for Lake Champlain, we're mainly concerned with phosphorus and the algae blooms that phosphorus contributes to. What happens is you get this limiting nutrient that now you have a sudden excess of, and then algae start to proliferate at a high rate. The algae can put off certain toxins that just cannot be removed by our typical drinking water processes. So everybody who's getting their drinking water from Lake Champlain, when you have an algae bloom, there are certain types of algae that put off these toxins. And again, we don't know how to effectively remove them with our current, municipal drinking water treatment plants. I always point to the Toledo water crisis some years back. It's a major American city on Lake Erie. Millions of people, their entire city's water system had to be shut down because of toxins from algae. And then the algae that have proliferated, they die, and other bacteria eat essentially the dead bodies of the algae, and they eat oxygen. So in addition to having the algae bloom, you have oxygen depletion when you have excess phosphorus. So we've got a couple years worth of study that we've done. Part of our initial goal at the agency is really just to identify and define, what's in the various waste streams, and look at some of the chemicals that are being used, some of the cleaning chemicals, and see which ones, maybe have phosphorus or have high sugar and contribute to high BOD. So one of the things was just getting a handle on what's the relative volumes of waste streams. So I kind of have this sort of process schematic, and this is based on just an arbitrary 100 gallons of sap coming into the Sugarhouse. For a RO that's maybe a higher breaks RO going up to 20, you're going to have about 90 gallons of permeate. But we also wanted to get a handle on how much RO wash water volume is being generated, what's in it, what's in the evaporator wash water, and how much volume is it. We want to evaluate what's the feasibility of capturing some of these waste streams. Is it feasible? Is it economical for you as a producer to implement some of these things? And those are the questions kind of we're aiming to answer with some of our studies. So this is a little bit about a study the previous person did in 2018 sugaring season. We have a facility near here, one of the larger ones, and we had a few sampling points, and this was just some really preliminary, grab samples. We had 4 sampling locations, so everything coming out of this particular sugar house was coming out of a pipe into a ditch at location number 1. And there was a ditch that comes down, flows down up to point 2. And these are just the 4 sampling points for some real preliminary stuff that was done in 2018. And then there was a receiving stream, and so he also sampled just upstream and just downstream of the ditch that is carrying everything coming out of the sugar house. That's 3 is upstream and 4 is right downstream. So it's really just a few grab samples. The results were of limited value just because it's kind of hard to time, grab samples just right. But I'll show you some of the results from that one. And here's a picture kind of right at the outlet pipe. On the face of it, that doesn't really look good outside of your sugar house, in a ditch that flows right to a stream. Let's jump into the numbers there. So part of the goal of that year's study was to try to grab samples during different modes of operation. So one of the first ones was when they were just sugaring and it was just permeate coming out of the pipe. So he tried to sample at that point. And then later he tried to sample when there was an RO wash cycle going on. And then also there was another sampling point, a time when they were sampling when there was they were dumping out the evaporator pan acid that had been neutralized. So this is when permeate is coming out. You write out coming out of the pipe. pH is in a pretty neutral range. BOD is like at a 2, which is very low. For context, your typical household waste that goes into your septic system has a BOD of about 250, and household waste has a phosphorus of about 12,000 micrograms per liter. But so coming out of the pipe, the permeate looks pretty clean. It's got a relatively low phosphorus and low BOD. And you see the other, downstream, there's actually more phosphorus already in the water than was in the permeate, it seems to say on this one. Later, we tried to sample when there was an RO wash cycle and a rinse flush going on. And here, now you see that the BOD numbers have jumped up. Now you're at like 373, which is a lot higher than what's going into a typical septic system. The phosphorus is really high. You're now at 33,000, whereas previously you were at a couple hundred. So by the time you get down to the end of the ditch, it's diluted, or maybe samples were grabbed at not exactly the right time. But overall, by the time you get downstream, it seems to just get diluted. So maybe it's not having necessarily a bad effect on the receiving stream. But again, it's kind of tough to really say that with certainty based on just how the samples were taken in this initial study. And then we get to the evaporator pan wash water when that was being discharged. So that is typically people use concentrated phosphoric acid, and you soak your pans in that. And when that was coming out of the tailpipe, now you've jumped up from 33,000, now you're up to 2 million. So concentration's gone really high. That's a lot of phosphorus. And again, for context, out in the main lake of Lake Champlain, we're looking to have 10 to 50 micrograms per liter, and this has got 2 million. So that's an issue. By the time you get to the end of the ditch, things have diluted, or you've kind of you don't grab it at the right time. It's, gone down a little bit to 26,000. Then you see just upstream and just downstream, perhaps you're seeing that, this ditch that's flowing into the stream is causing a jump in the phosphorus levels. The other thing you'll see is there's a lot of BOD in this evaporator wash water. So these are definitely things that are of concern. They can't be discharged into the water. So definitely, we think the evaporator pan acid, is one of the bigger concerns. But we also, we're continuing to look at the RO wash water. There's a lot of sugar in that. So some of the real simple things that, we always try to say is to make sure you use permeate and flush out any sugar that's in there before you start your wash cycle. I imagine most people do that because you don't want to lose sugar. Try to get all the sugar out of there before you start the RO wash. And anything that goes out the door, always want to adjust to a neutral pH. So, pH definitely you want to neutralize, and you want to be aware of anything that's still got a lot of sugar in it with high BOD. Let me move on. So kind of the preliminary conclusions we had is that regarding phosphorus, which is really one of the main concerns here, most of the loading is all due to the evaporator wash water. There's relatively a very small amount of phosphorus in the other waste streams. But the evaporator pan wash water is also one of the smaller volumes that are generated during the course of the season. So we think that is probably the most feasible thing to try to capture. A typical producer may only use a gallon and a half or two of concentrated acid over the course of the season. That obviously gets diluted 60 or 80 times. So you've got 100 to 500 gallons or something of diluted phosphoric acid. And that being a relatively small volume, we think it's a fair thing to ask people to try to capture that. One of the issues with discharging waste from the sugar house during sugar season is simply the season. Things are cold, the ground is saturated and wet or frozen, and in that condition, things that are discharged to the surface of the ground are just going to run off. They're not going to infiltrate. So, especially for the neutralized phosphoric acid, if that could be retained, then ideally it would be spread as a fertilizer over cropland or something like that. At a time, at a season where it will actually infiltrate into the ground rather than run off into the stream. So, like in each gallon of concentrated acid, there's three or four pounds of elemental phosphorus. Then you dilute that. When you dilute it, it doesn't really change the amount of total phosphorus in there. One of the things we also looked at is, are these numbers even relevant to the tons that we're talking about for the TMDL? And we'll get to that. So again, first steps, like the bare minimum things that the agency from a regulatory perspective we're asking folks to do is try to capture the phosphoric acid if that's the product that you want to continue to use to clean your evaporator pans. It should be a relatively small volume. We think it's a feasible thing to ask. Some other ways to reduce the amount of phosphoric acid that you use. Some people implement recycle systems. So they'll use it, they'll soak their pans for a while, and then they'll hold on to that and reuse it 2 or 3 times before it's spent. And then maybe they'll top it off with a little fresh acid to keep that pH low. So anything you can do to minimize the amount you're using. Other people have found good results with just simply soaking their pans in Permeate overnight. And then maybe not using phosphoric acid at all. There are some other acids that can be used, and there's a wide variety of types of operations. Some people are only sugaring for a few hours a day. Other people are sugaring for 18 hours a day because they're just on a different scale. There's a lot of different things that may or may not work for you. There are some alternatives that folks have tried, such as sulfamic acid, acetic acid is another one. I think all of these are available at CDL or LaPierre, whoever your distributor is for products. So that's one of the things I want to do is continue to try to work with those folks to, because they're going to have contact with all of you to suggest alternatives. So, ask them if there's alternatives that they would suggest. Those are some of them. And, I'd suggest try to give them a shot and see if it could work for your operation. The other thing is the RO wash water. When you first start to flush out that RO wash, that first plug of water is pretty high in a lot of things. And so we're going to continue to look at, most people flush for like an hour or so after they do their wash, but really it's only maybe the first 10 minutes that are highest in things that we're concerned about from a water quality perspective. some common questions I get is, regarding phosphorus is, some people think that if you neutralize the acid, that gets rid of the phosphorus, but that just fixes the pH, which you do have to do that. You have to fix the pH before you can let it go, but it doesn't remove the phosphorus, so that's going to stay there. Again, reiterating that due to the season, and remind yourselves that dairy farmers are forbidden from spreading manure typically on frozen grounds, except for under limited emergency circumstances. It's the same concept for maple. Just realizing that due to the season, things are going to have a high probability of running off and reaching a surface water. Another thing is at the front of the season, some people tend to dump raw sap for whatever reason, and that has a lot of sugar. So try to be mindful that you're bringing all of this product from your entire sugar bush to a single location. Now you're potentially dropping it into a stream. You've kind of brought a lot of material into one location, which can cause issues for the receiving water. So some of the questions we're continuing to look at is looking at different RO membranes and seeing if there's some different effect on what's coming out. We wanted to look at Permeate also because that's probably the largest volume of waste that's going to come out of the Sugarhouse. Everybody thinks that it's supposed to be just clean, clear water, and that it's safe to discharge. So one of the things we wanted to really answer is getting some data on Permeate to justify that assertion, and to really have some defensible data to protect the practice of being able to just discharge a Permeate, because we realize that for most people, because Permeate's the largest volume of waste, it's going to be the least feasible to implement like storage or treatment for. So we really wanted to just collect data on Permeate and prove that whether or not it is clean enough to discharge. So some of the membranes potentially could leak sugar, enough sugar that could cause a water quality issue. So in 2019, we had about 15 different facilities, folks that have worked with us, allowed us to come and collect samples. We tested raw sap just to get some base numbers on that, and we collected a lot of samples on Permeate. And the other thing we focused on last year was the RO wash water. So, that RO wash cycle, you put in your soap, you've got a recirculation tank that recirculates for a while, and then temperature slowly rises through the pump, and then it shuts off, and then after all that, you flush it. So we tried to get a sample at time 0, and then every 2 minutes afterwards of that RO wash to try to get a sense of what's in that. And so I've got a lot of data, and only a tiny portion of it I'm able to really work into the presentation at this time. We're still awaiting a final report from an outside consultant that the agency has hired to kind of compile all this stuff. But here's a few example things that we looked at for RO wash water. So again, as you go to the right, that's time, and these are graphs of a few different parameters that we're looking at. So your typical RO soap has sodium hydroxide, which is a high pH. So you see when it first starts to discharge, you're at a high pH, and then you're flushing the whole thing with typically Permeate water, and then the pH kind of falls down to a safer level that is about the same as Permeate. And then we also looked at BOD, which again is a measure of how much sugar is in that. Household waste is at about 250, so the front end of that RO flush is pretty high in BOD. But as you go down about 10, 20 minutes, it's dropped a lot. You kind of see a decay curve there. Conductivity is really just a measure of dissolved salts and ions. And again, you got a really high number here. And by the time you're about 10 minutes in, it's really low. We're looking at conductivity as a potential, that's something that's easily measured with relatively expensive probes. If we can identify something that you can measure easily that kind of serves as a proxy indicator for when the other things that are in the RO wash have been flushed, then the idea is that maybe you only had to collect that first 10 minutes of the RO wash, and then you can flip a valve and the rest could potentially be safely discharged. We don't really have a definitive answer because we have a lot of different graphs, and across facilities there's a lot of different things going on, and it doesn't always sort of make sense from one facility to the other. Again, phosphorus, it's got a high flush up front. One of the things we realize is that there are a few RO membrane cleaning products that still contain phosphorus. Many of them don't, but I would highly encourage you to consider switching to one that does not have polyphosphate in it. That's one simple thing that you can do. Definitely ask your distributor for the MSDS sheet and look at the actual chemicals that are in your RO soap. Try to pick something that doesn't have phosphorus, and that would eliminate a lot of the concern there. And then we had Permeate. One I'm going to show you is BOD. So we've got about 18 different samples that have a BOD in the 0 to 20 range, which is very good. That's clean. That's what's typical of a clean river or stream. But we had just a few samples that came up a little bit higher. So we want to kind of investigate what maybe was going on at these few facilities that had a high amount of sugar in their permeate. One of the things we've kind of realized is that there's kind of two different perspectives at work for BOD. So from a sugar making perspective, this amount of sugar is really a negligible amount for your operational bottom line, but it can be a significant amount of sugar from a water quality perspective. So if your membrane is passing maybe 1 or 2% of your sugar that was in the raw sap, that's maybe an acceptable loss, from a business standpoint, but not necessarily a good thing from a water quality standpoint. So we want to kind of work to figure out, what exactly is going on at just a couple of places where we saw higher BOD levels in the permeate. Whether it was just, cross-contamination with other things, or if it's an issue with the membrane. So we're going to continue to look at that. But overall, permeate typically is pretty clean. There's a lot of data, and again, we're still waiting on final report. This all collated, put together. I showed this slide before. Previously, it was for 100 gallons of sap coming into the sugar house. Again, to illustrate the size, the sense of scale and the wide, we've got very small producers and very large producers. This is for, a hypothetical facility that has 200,000 taps. Now, over the course of the season, you've got maybe 3-point-something million gallons of sap coming in, and now you've got 3 million gallons of permeate water. And when you get to these higher volumes, that's why we definitely want to make sure, that the permeate water is definitely clean, because that's just a different, sense of scale here. One of the things as the agency considers, additional rules regarding maple is a sort of tiered system like we have for dairy farms. We have large farms, medium farms, small farms, and the largest farms have to meet tougher standards and tougher rules. And so we may end up at, something like that for maple, where the largest producers, have to face, tougher regulations and maybe have to get their permeate tested to prove that it's clean before they're allowed to discharge it. So, that's just another, part of the conversation is, what's the scale that we're talking about. And again, so for like that particular facility, they're using a lot more of the concentrated acid. They're using maybe 200 gallons of concentrated phosphoric acid in a season. And when you kind of do the math, figure out, what's the total mass there, and then you try to put that in perspective with some TMDL numbers, you kind of really see, some calculations here. So 200 something gallons of concentrated acid is, 830 pounds of phosphorus in one short maple season. Whereas when you look at the required reductions that we have to achieve in, say, St. Albans Bay, the amount that this one producer would be using is like 20% of the reduction we have to achieve in all of St. Albans Bay. So there are actually significant levels here, potentially, especially for the larger producers. And, with a lot of very small producers, it starts to add up. So we realize that they are actually, relevant numbers. I did want to just spend some time to, answer any questions, and just reiterate, we want, as an agency, to work with the industry to make sure that we have rules in place that are feasible for folks to implement, that are fair. And so, we definitely want to get folks' input, as we, in the next few years, potentially have rules that are written specifically for maple. I think in all instances, we're going to ask folks to, at a bare minimum, capture all of their phosphoric acid, pan cleaner. I think that's the simplest thing and easiest thing for folks to do. And for most people, that's really just a matter of getting an extra tote, to store that in and separating that waste stream.
You store it, capture it, and release it onto
Thought ground.
So in a perfect world,
Thought ground.
yeah. So maybe for every gallon of concentrated acid, to spread that at an agronomic rate really takes like an acre or two of like cropland. That's the perfect world. What would be, less ideal, but certainly better than letting it go out during maple season is storing it until summer and then just trying to spread it on ground that has thawed, where it will actually soak into the ground. You can use it as a fertilizer. It essentially is fertilizer. I've got one producer who also has a Christmas tree farm, and he's looking to basically replace the phosphate fertilizer that he uses and just use his waste acid. Because once you've neutralized it to a safe pH, it's phosphate, and it's a valuable fertilizer that could be used. So,
Is there a reason you couldn't just take that to like the dairy farm?
that's another option. I'm glad you mentioned that. Now, if you have a relationship with the local dairy farmer, yes, you could take that and put that in their manure pit, and that is a viable option because then they have the equipment to spread that properly come late spring, summertime. But not everybody necessarily has that option. So but for those that do, that's certainly something that could be considered.
The flip side to that is that dairy farmers they're having so much property that they need to control and manage in order to get rid of their own phosphorus, let alone additional.
Sure.
And so as a result, if I was a dairy operator, I'd say, I don't want anybody else's problems.
I agree. It could potentially be an issue. So if you are a very large maple producer, the amount of phosphorus you're bringing into that dairy farm could potentially need to be incorporated into their certified nutrient management plan,
Right.
their NMP. So on a volume basis, it's typically it's a small amount of volume. It's hardly going to put a dent in most folks that have adequate manure storage.
The issue though is the amount of phosphorus.
So it could potentially, depending on how much they're importing, could possibly change their the phosphorus levels. But they have to test their manure already anyway as part of their NMP. So it may change that a little bit. I haven't run all the numbers there, but you're right.
What about pumping it into a leach field? Is that a good way to go? Or?
If you have that set up, that's potentially an option. I will say that for the phosphoric acid there's so much phosphorus in that, it could potentially overload that system on a phosphorus level.
Well,
That said, soil does have a high capacity to bind phosphorus, which, is not necessarily the case for things like nitrogen, which is very highly mobile in groundwater. But phosphorus, typically takes a handful of forms and many of those forms can essentially bind to soil particles containing iron and aluminum, that sort of thing. I'd still say potentially you might want to separate, the pan acid waste stream, but a leach field could certainly be a feasible thing for the RO wash water. Again, that can be a significant infrastructure investment on your part. If you have that available nearby, you could potentially send that there. But you kind of got to balance. It can be pretty costly to put in a leach field. So.
You mentioned a couple alternative acids for pan cleaning.
Sure.
Are there other concerns with those? Do they just not work as well? Is that why, that's not straightforward?
Some folks have told me that they feel like these other acids work better. Other folks have told me that they won't switch. But again, this one guy who says I won't switch, they boil for 18 hours a day in shifts, and it's just a different, management style, different type of operation. Other folks that, do it on a smaller scale are maybe boiling for 3 to 6 hours, and then they can let their pans sit and permeate and soak in that, overnight, and then, a little elbow grease will kind of do the trick. So one of the alternatives we want to look at is sulfamic acid, which comes as like a powder that then you mix with water. That does have sulfur, but it doesn't have, phosphorus or nitrogen, so it's less of a concern. You still have to neutralize the pH, though, to a neutral level using baking soda. Is a typical easy way to neutralize it.
Am I hearing that perhaps that neutralized phosphoric acid will be, my balsam trees would like that, would be good for the greenery?
No, I'm not an arborist, but yes. It is a fertilizer, so, you could use it in a garden. It's chemically, it's no different from the phosphate, that's in a lot of other.
Just looking to make my balsams greener for,
Yes,
for
that's
refresh.
I do think it can be beneficially used as a fertilizer. So once the pH is neutralized.
Well, I was gonna say, couldn't we take that in the sugar wood and fertilize the maples with it?
Potentially. Again, there's the question of when is that happening? Is that happening, in March, April, during sugar season, when it's not going to soak in and really be of any benefit?
Well, probably summertime then.
But yeah, if you can spread it out over a large, ground area when it will infiltrate, that's certainly better than releasing it from a point source, in the winter. That will always, be better for water quality.
So could you just clarify for me, I think you said at the beginning of the Q&A, at a bare minimum, the regs are likely to be that we're going to be required to capture wash water. Is that both pan and RO?
Like permeate?
Yep.
RO
wash water.
The RO wash water is kind of an open question. Most people flush that RO wash soap with permeate.
Mm-hmm.
So kind of the question is can we determine, what's a certain amount that you should capture, at the first plug of that flush,
Yep.
and then after a certain amount of time or unit volumes, at what point is it close enough to permeate that it's safe to discharge? I can't really answer, again, not being a regulator and just being an engineer and trying to just, put the numbers out there. I don't know where we're going to land on that. It's quite possible that folks will have to capture that RO wash water or some portion of it. Mm-hmm. There's also, again, the question of scale. And, if there's rules written, currently we're not inspecting maple operations. And if we ever started, we'd have to start with the largest operations. And then, it's just a lot of workload, we are not set up to do. So that's where it would start, is with large folks. And a lot of large operations are just kind of, proactively planning for that eventuality. So.
Jason, I guess the question I have is there are places where there is no phosphorus entering the streams, at least what you're seeing. So, and they may be far enough away from streams and so forth, and it's not really causing a problem. So, I guess, does this have to apply to everybody, even though sugar bushes aren't having a problem because they're not discharging into a stream?
I mean, it's a really site-specific question. And everybody's site is different. A lot of sugar houses tend to be at low-lying spots very close to receiving streams. Some have the advantage of perhaps being located at a spot where if you dumped it on the ground outside of the sugar house, it does have a long way to go before it reaches surface water. So that's kind of the challenge for regulators is to write rules that cover such a wide variety of circumstances and situations. It's it's so different from sugar house to sugar house. And again, even if you're 500 feet, if you're when it's that time of year, it's got a high likelihood of just kind of running off the surface, whether you can see it or not. It's probably just going to run right over the top and head towards the nearest ditch and then to the next stream. So I don't know if that quite answered the question, but come back at me and
Well, because we've been participating, and
Sure.
and then with the samples that are collected, that there was no indication that anything reaches a brook that we're far enough away from a brook.
Yeah.
So, for the 20 years we've been doing it, it seems like everything that we have in our structure, everything works. And I'm sure there's other sugar makers in the same situation. So why should then they have to put in containment system if what they're doing is adequate?
Again, and it's a really site-specific evaluation to answer that question. I will say it's very hard to answer that because it comes out at one spot and then you try to follow it 500 feet to the nearest brook or stream. It's going to get diluted, and you have to take a bunch of samples to really kind of. I mean, it doesn't necessarily go away. It just gets diluted to a point where it's still all going there, but it's kind of spread out enough that it doesn't get there at the same time. So, mass loading is sort of kind of independent of concentration. I guess is kind of the counter argument I give to that. The amount of phosphorus that comes out is going to be there. If it's all running off but kind of getting diluted in that process, just because it's dilute when it all gets there, it doesn't mean that it's not all there.
But it may then get absorbed through all the plants throughout the summer and taken all up.
That's
and
assuming
turned
that
into-
it gets into the ground during that time of the year. So when the ground is already saturated with snow water or just outright frozen, nothing's going to infiltrate. So, it's just gonna kind of get diluted and then all run off. So, and that's why typically you can't spread manure on the snow because a lot of it's gonna run off. So that so if you can allocate that little bit of storage for your phosphoric acid waste stream and save that until summer, I mean that's a huge improvement. That alleviates a lot of the concern, the potential concern coming from sugar houses.
So on that subject, can you just give a sort of a visual of what, a 4,000 tap sugar bush would need for storage for wash water?
So, 4,000 taps, so...
Or if I pick a number, whatever it is, per thousand or something.
So, I guess the benchmark number I've been looking at for like phosphoric acid is that people use, for every 1,000 gallons of finished syrup production, they're using anywhere from half a gallon to 2 or 3 gallons of concentrated phosphoric acid. So if you're making 5,000 gallons of syrup, then you're potentially, using 2.5 to 15 or 20 gallons of, do the math there. Yeah, it's really kind of dependent on how much you dilute that phosphoric acid. Typical recommendation is, 60 to 80 times, I think. So you just ask yourself, how much do you go through in a season? And that depends on your size. So if you're going through a gallon and diluting it, maybe 100 times with other wash waters and thing, then now you've got 100 gallons. That's a relatively small ask, I think. I think that's a typical amount of, concentrated acid is a gallon or two for a lot of producers. So now you're looking at 100 to 200 gallons potentially of storage. So, one of those square, tote tanks or something, if you got an extra one of those, that should be sufficient for a lot of folks. And if you're on the higher end, you're in a different level anyway, and you really need to be kind of, on the ball there. So, it's a relatively small volume, but.
Yeah. Well, because I've been to this segment for 3 years in a row now.
Sure.
And I think your presentations are getting more and more refined. I think it's great. A visual of what that looks like would be helpful, because I think from a regulatory standpoint, when it does go there, people are going to want to be able to understand exactly what the configuration wants to be when somebody comes knocking on the door and says, hey, are you collecting it or not?
Yeah, and so we would ask some basic numbers, like what's your total, how many taps do you have, how many, from taps, or from how many gallons of tap you bring in, or some of those other, we've got established benchmark ranges to tell, approximately how much you might be going through. And so that could be you're in this range. It's not too hard to kind of do that math. Again, if you're just using a gallon or two per season, it's one of those square, bulk totes that, come with IBC tote tanks. Yeah, I think most people have seen those around. So, and that's probably good for most folks. If you want, we offer free technical assistance as an agency in the engineering section. If you want to implement this, give us a call. We can help you estimate some of those numbers. Again, just asking yourself how much of the concentrated acid do you typically go through in a season. That's a good starting point to estimate the total volume for evaporator pan acid. The RO wash, we're still kind of working on that. And we are implementing a few pilot projects. One is a 2-tank system at a large Maple facility. There's a smaller first tank that's used to, he draws off that evaporator pan acid and reuses it 2 or 3 times. After it's sort of spent, it'll go to a larger final disposal tank that will be buried underground, and it'll be pH neutralized. And so by recycling it and reusing it, they're hoping to reduce the total amount of acid they're using per season, which is a significant cost savings because phosphoric acid isn't cheap. So it's kind of helpful for their bottom line, and it provides storage for it. The other pilot project we're looking at is the irrigation for the Christmas tree farm that he has nearby. So that's the other thing is, if folks want to implement a system, feel free to drop me an email and we can look at, because we are looking to pilot a few sample pilot projects to evaluate different approaches to management. So
you kind of just touched on it, but I think like what Chris was saying, I think a lot of sugar makers are going to be concerned, am I going to have to put in thousands of gallons of storage to hang on to this till a time I can safely get rid of it.
yeah.
But I think, especially with the pan acid, the pan cleaner, is, you can kind of figure that out by how much volume your evaporator holds,
Yeah.
when you fill it up to put the pan acid in. And I think a lot of people are going to want to start collecting that, saving it, reusing it, because that's, like you said, that's a huge cost savings.
Sure.
Because you cut down on the volume, you just add a little bit more acid to get your pH back
Yep.
where it needs to be. So I think with people, even a really big operation, 1,000 gallons of that storage is gonna be plenty.
Yeah, I think so for a lot of folks.
And that's a pretty easy ask for people to do.
Especially on the larger end.
Absolutely.
And again, for some of the smaller folks, you know, it's
100 gallons of storage, yeah.
it's not a huge ask, and that's kind of our take. I mean, keep in perspective that, you know, phosphate in, you know, household detergents have been banned since the 70s, and now we're at 2020. You know, it's kind of been a long time coming that, you know, we're trying to work to get phosphorus out of the waterways. You know, in a way, it's kind of gone on too long, I think. But again, I think it's feasible for a lot of small folks to implement a small storage system. Again, kind of part of the unanswered question is, what do you do with it? And, you know, we have a few suggestions, but it may not work for everybody. Not everybody's going to have a local dairy farmer that they have a relationship with, or, you know, that's willing to take that in. Wastewater municipal plants, they're not going to want to take it. They have to discharge, you know, down to 10 to 20 micrograms per liter. They're not going to want to take on this phosphorus loading at all. You know, and so irrigation systems and pumps is not going to be feasible for very small maple operations. But, you know, releasing it in the summertime on dry ground is going to be better than the current situation. So.
Are there acid substitutes that eliminate all of the water quality concerns with pan wash?
So, you know, some people, you know, there's a wide variety of management styles. You know, some people, you know, soak their pans in acid way more frequently than others. You know, some people may only use phosphoric acid a few times per season when that niter buildup gets really bad. The rest of the time, on a daily basis, maybe they're soaking in Permeate. So, you know, ask yourself, what is your current usage, and consider trying, you know, something else, if, you know, and seeing if that is viable for your operation.
But there are alternatives that have no phosphorus.
Yes, sulfamic acid is one, acetic acid is another, which is just concentrated vinegar, really. Those are potential alternatives that don't have phosphorus in them. Yes, they still need to be neutralized for pH using something like baking soda as a cheap way to neutralize acid, but they don't have the phosphorus, and that does address, you know, a huge water quality concern.
When you say you use baking soda, is feed grade baking soda permissible?
Food grade?
Feed grade for dairy cattle.
I mean, I think any grade of baking soda would be fine, you know, especially if it's going out the door, ultimately, for disposal. I don't think I mean, just the kind that you'd buy at the grocery store is fine, you know, Arm & Hammer or whatever. I mean, it's just baking soda, so. I don't know really what would be the difference between that grade, so to speak.
Sodium bicarbonate.
Yeah. NaHCO3, that's, you know.
Exactly.
What's the active ingredient in RO wash?
I don't have it on this. So I have a list of, like,
Okay, you're saying the RO wash is more basic, and
Yeah.
whereas the pan wash is acidic.
Yeah,
right?
so typically you're going to have sodium hydroxide that causes the high pH in the RO soap. There's a few other things. You know, it depends on the particular product you're using. You know, I do have a compilation of, you know, what's in each product.
Okay, is there any potential benefit from the RO wash reg?
Benefit for...
Well, I mean, okay, the pan wash, you can save it and fertilize with it.
Sure.
What's the RO rinsing good for?
I mean, it
Anything?
has some phosphorus in it, so, you know...
But not much.
Not nearly as much as, you
Is
know,
it
maybe 100 times less than,
Anything good that can happen with that?
you know, it could be, you know, land applied if the season were right. But, you know, mainly it's gonna be sugar, and
Well, I mean, in our system, they just let it run with the permeate and rinse it. They use the permeate to rinse it out, and so it isn't really quantified and gatherable unless you go out to the other end of the pipe, I guess.
yeah, and that's, you know, we're trying to, I mean, you know, we've
Whereas-
got some
whereas
numbers.
washing the pan, you know you've got the content of the pan, and when you drain it out, that's what you got.
Yeah, I mean, there's not a whole lot of nitrogen in the RO wash, but, you know, at the front end of that flush, there can be, you know, several hundred to a couple thousand micrograms of phosphorus. Contrast that with that pan acid, which may, you know, be in the millions of micrograms per liter. That's, you know, multiple orders of magnitude kind of difference. You know, land application, if the season were right, is a potential alternative. But when you talk about the RO wash, your volumes are getting bigger, and so implementing
Yeah.
storage becomes less and less
Yeah,
feasible.
It's more diluted.
So I don't know. I mean, that's kind of how do we kind of examine what's the most feasible thing? Do you capture the first 10 minutes, or you know? And I can't just say 10 minutes to everybody. You
Yeah.
know, it's going to be different
Mhm.
based on the facility. So otherwise, it's just a little bit of sugar and some phosphorus, you know, and some salts and things that are in that or wash water.
There's no treatment, like if you combine the RO alkaline wash with the acid and you still end up, the phosphorus doesn't precipitate out, there's no way to separate that.
No, that phosphorus is going to remain in the phosphate form, which is going to remain dissolved. It's not going to precipitate out as a solid. You know, and so nitrogen is one where under certain circumstances, nitrogen can get turned into nitrogen gas and gasify. You know, most of it's going to stay in the nitrate or nitrite form or potentially an ammonia form. And that's going to all, you know, stay in groundwater.
So something like a lagoon is not, let's say, dump everything in the lagoon, it balances itself out.
I mean, so we have pretty strict standards for lagoons when it comes to, you know, dairy operations and, you know, the permeability of the soil that is in that lagoon. A lot of folks, I mean, have to put these, you know, 80 mil plastic liners in their lagoons because they don't have the right soils, or they're building concrete pits. But, you know, this is on a larger volume scale for, you know, for dairy operations. I think, yes, that could be an alternative, but it's a huge infrastructure investment that, you know, you could be looking at $20,000, $50,000. You know, we realize that's not, you know, unless you're very large.
I kind of did a lagoon behind my sugar house so that stuff would flow out, would go in the lagoon. I thought it would kind of settle in before it then would kind of go out. But guess what? Ground's frozen, it doesn't work.
Yeah.
It fills up and then it just flows over. It doesn't really seep in.
And it's,
You know, towards
yeah.
the end of the season, there'll be a little seepage into the soil, but for the most part, I mean, I don't know if it was a wasted effort or not, but, you know, it doesn't really work. 'Cause of the
And
ground's
like for the
frozen.
phosphorus, it's not going to solidify or precipitate out, so it's going to stay dissolved and it's going to keep going. So, yeah. So unless that's a closed system that just fills up and then you know, are pumping it into a spreader tanker, you know.
Yeah.
But you know, yeah, we realize that's not.
Water builds up after a
Yeah.
while, runs liquid.
Well, the other thing, phosphorus builds up in the soil. Our crops don't use a whole lot of phosphorus compared to nitrogen and potash. And so as a result, we gotta watch out how much we put on.
Yeah.
And whether it's trees or whether it's alfalfa or corn, whatever, we need to keep that balance going
Yeah.
all the time. And so we need to take a look at soil samples over a period of time. Not only the soil samples, but also look at how much we are applying and,
Yeah.
what the concentration is, in the soil at the time that we start and when we finish.
Definitely, especially, if you're on the larger side of things and are trying to land apply at proper agronomic rates. I
Right.
mean, my real spitball, guess is, for every gallon or so, you need an acre or two.
Yeah.
A gallon of concentrated acid. Obviously, that gets diluted to a larger volume, but you kind of bring it back to that, starting mass that's in that concentrated acid. And yeah, it can build up over time, especially if you're dumping it in one spot.
That's how we got into this problem.
Yeah, so if you can not use phosphorus-based products, that's that's the quickest answer for a lot of the water quality concern. Or minimize the amount you use. So definitely look, if anybody's interested in, trying to implement pilot projects for addressing some of these, we do have grant programs. They pay up to 90% of the construction costs. Contact me, look me up on the agency's website. I'd love to get an email and chat. So, thank you, everybody.
Thanks, Jason.
Thank you.
Thank you a lot.